In this video, we are going to look at the unit circle, which is a very useful tool in understanding trigonometric ratios that are greater than 90 degrees, and it will help when we start to solve trig equations. To draw the unit circle, we first draw the x and the y axes. We then draw a circle with the center of the circle at the origin, and it has a radius of 1 unit, hence the unit circle. Because this is a unit circle with radius 1, we actually will know the coordinates of where the circle meets each of the axes. So along the positive x-axis, we've gone over to the right 1, and we've not gone up or down because we're on the axis. So that means this point has a coordinate when x is 1 and y is 0. And then going to the positive y-axis, we have not gone left or right, so x is 0, but we've gone up 1 because it has a radius of 1 on this circle. So this point has a coordinate 0, 1. And then going along the negative x-axis, again, we have a radius of 1, but this time we're going to the left. So the x value is negative 1, the y value is 0. And then finally, when the y-axis is negative, we've gone to the left and right 0, but we've gone down 1. So we know the 4 points where the unit circle meets the axes. Now let's look if we choose another point on that unit circle. So let's just choose this point here, P. So this point has coordinates x, y. So it represents any point on the circle. We can then form a right angle triangle. So from the origin, we go to the point, and then we drop straight down. So we are parallel to the y-axis, and we go over. So we have a right angle triangle. You can see the hypotenuse of the triangle, which is across from the right angle. And this hypotenuse is the same length as the radius of the circle because we are going from the center of the circle to the circumference of the circle. So we can label this r for the radius, and we know this is a unit circle, so the radius is equal to 1. I'm also going to label the other two sides in the triangle. The bottom length going from the origin along the positive x-axis to where the triangle ends, I am going to call x, which just represents the length of the triangle along the x-axis. The side length that goes parallel to the y-axis up to the point on the circle where the triangle ends, I am going to call y. And remember, this point P has coordinates x, y. So to get to x, we had to go x units over to the right. To get to y, we had to go y units up. So the coordinates just represent the distance you have to move from the origin in the x direction and in the y direction. And finally, we have this angle, theta, which is formed between the positive x-axis and the radius or the hypotenuse of this triangle. Theta, the angle, always starts at the positive x-axis and moves in the counterclockwise direction. So now that we have our right angle triangle set up within the unit circle and we've labeled all the sides, we are going to talk about the basic trig ratios. So the ratios for sine, cos, and then we'll talk about tan. So we know that the sine ratio is equal to the length opposite of the angle divided by the hypotenuse of the triangle. So looking at this right angle triangle and this unit circle, we know where theta is. So sine of this angle theta is the opposite. So the opposite length we've labeled y, and the hypotenuse we've labeled as the radius, and we actually know the value of that. It is equal to 1. So what we can say is that the sine theta is equal to y over the radius, and then we can substitute in 1 for the radius. And when you divide y by 1, you are left with simply y. So we can say that sine theta is equal to y. So if we know the y value of this triangle, we know what the sine ratio for this angle is. And similarly, for the cosine ratio, which we know is adjacent over hypotenuse, we can take the adjacent length, which is x, that is adjacent to this angle, and the hypotenuse is, again, the radius. So cos theta is equal to x divided by the radius, and then we can substitute in for the radius. So cos theta is equal to x divided by 1. So to simplify, cos theta is equal to x. And now we can just fill that in on the unit circle. So this length x on a unit circle, when the radius is 1, is equivalent to the cos theta. And this length y is equal to sine theta. We will mostly be working with the sine and cosine ratios, but we could find this tan ratio as well. We know that the tan ratio is opposite over adjacent, so that is y divided by x. Or you can say that it's, instead of using y and x, you can use sine and cos. So the opposite of theta is sine, and the adjacent of theta is cos, and that's actually something called a trigonometric identity. So I will just write that down. Tan theta is equal to the opposite length. The opposite of the angle is y, adjacent of the angle is x. Or we can use the other two ratios. So if you know the sine ratio and you know the cos ratio, you can easily divide those two to find the tan ratio. So now we will use the unit circle and our knowledge of the coordinate axis and when x is positive and negative and when y is positive and negative. And that is going to help us identify when trig ratios are positive and negative. So to begin with, we are going to first look at acute angles, which are angles between 0 and 90 degrees, and obtuse angles, which are between 90 and 180 degrees. So on the unit circle, 0 degrees would be along the x-axis. So going in the counterclockwise direction, the y-axis would be 90 degrees. So acute angles will fall in quadrant 1 between 0 and 90. Obtuse angles are between 90 degrees, so we've gone 90 degrees, and then we're going to keep going counterclockwise to 180 degrees, so that's where the x-axis is negative. So acute angles lie within this first quadrant, and in this first quadrant, x is positive and y is positive. So that means any sine ratio of an acute angle or cos ratio of an acute angle are positive as well. And that means tan will also be positive because a positive divided by a positive is also positive. But when you look at an obtuse angle, so you make a right angle triangle in the second quadrant, so the angle starts at the positive x-axis and goes in the clockwise direction, it's greater than 90 degrees, and that's where you draw your hypotenuse of your triangle, or the radius, to the circle. So you make this right angle triangle in quadrant 2. Here, your x value is negative because you've gone to the left. When x is negative, that means the cosine ratio is negative. Y is still positive because we're still going up along the y-axis, just like we did in the acute triangle. Now that means the sine ratio is still positive for obtuse angles. And we just saw that tan is equal to y divided by x, so a positive divided by a negative, so the tan ratio would be negative. We will look at what happens when you move past 180 degrees, so between 180 degrees and 360 degrees in the future. But you are not going to understand the full importance of this unit circle until we start solving trigonometric equations and realizing that there are more than one solution, and that is because of this unit circle. So we are going to do a lot more work using this unit circle, so make sure you understand how it works and where the labels are in terms of x, y, the radius is 1, and then where the circle meets the coordinate axes. So let's look at a few examples, just getting used to using this unit circle. Here we are asked to predict whether each value will be positive or negative, and we want to sketch that angle on the coordinate axis. So the first question is sine of 72. So we need to draw the coordinate axis. You can label xy if you'd like to, and then draw a circle. You may want to get used to writing the coordinates of where the unit circle meets the axes, which I've done here. And then since we want 72 degrees, I'm going to say where 0 degrees is at 90 degrees because 72 is somewhere between 0 and 90, so it's in quadrant 1. So then from the origin, you draw a line up that's 72 degrees from the positive x-axis. And then just draw that triangle down, drop it to the x-axis, and draw the right angle triangle. So this question asks, what sign is it, positive or negative? Well, we know that sine of our angle is y. So therefore here the y is positive. So sine of 72 we know is going to be positive. And if you check that with your calculator, you get sine of 72 is 0.95105 and so on. Remember to make sure your calculator is in degrees. So in the next question, we want cos of 125. So again, I drew the unit circle with some detail, and I started at 0 degrees. I'm going to pass 90, and so I'm going to lie somewhere between 90 and 180. So that angle is going to be around here. So 125 is this angle here. But when you go to draw the right angle triangle, you always just drop down from the point to the closest x-axis. So here I'm on the left side of the x-axis where x is negative. So when I drop it down, I am at a negative x value. And you can even find the angle inside the right angle triangle because along the x-axis is 180 degrees because it's a straight line. If outside the triangle from the positive x-axis is 125 degrees, inside the right angle triangle, what's left is 180, take away 125, which is 55 degrees. But let's get back to what the question is asking, which is what is the sine of cos 125? So we know that cos is equivalent to the x value. Here the x is on the left side, so x is negative. So that means that cos of 125 degrees is negative. And again, you can verify with your calculator, you get negative 0.57. So question 2 uses the same idea, but this time we're given the ratio and we're asked to find the angle. So between 0 and 180 degrees, we're restricted between acute and obtuse solutions. So in question A, what is the angle when cos of that angle is negative 0.7? Because we're actually solving this time, we will be using the calculator, but first we're going to set it up using the unit circle. So because we're given the cos ratio, really we're given the x value of that right angle triangle. It says move to the left by 0.7. So I'm going to label that as negative 0.7. And that means if I then go up and hit that point on the circle, I can then go to the origin and I form that right angle triangle. The angle we are looking for is from the positive x-axis to the hypotenuse of that right angle triangle. And we can see that that is an obtuse angle. So when I go and do this in my calculator, I should get an obtuse value. So remember to find an angle in trigonometry, you do the inverse of cos to the ratio, negative 0.7, and you get that the angle is 134 degrees. And you may be asking yourself, why do we have to do this whole process when we could just use our calculators? And that is because sometimes there's going to be more than one angle that gives us this ratio. This question restricted us between 0 and 180 degrees, so there's only one solution. But when we go past 180 degrees, there's actually going to be more than one solution. And that brings us to the second example. Sine theta equals 0.8. So I've set up the unit circle. I'm now looking for the sine theta. And remember that sine theta is equivalent to the y value. So really we're finding when y is equal to 0.8. So that means we want to draw the right angle triangle where the opposite of the angle is 0.8. So we're going 0.8 up the y-axis, but remember we want to touch the unit circle. So we want to go over here. We want to go 0.8 up and then drop down to the origin. So this y equals 0.8. So we're looking for this angle inside the right angle triangle from the positive x-axis to the hypotenuse. But you should also notice that there is another place where you could draw a right angle triangle in this top part of the unit circle that also has a y value of 0.8, and that's over here in quadrant 2. In quadrant 2, the x values are negative, but the y value is still positive. So I'm going to draw this other triangle over here that has a y value of 0.8, drop down to the origin, and this time you're looking for the angle that starts at the positive x-axis and goes around past 90 degrees to that hypotenuse. So our calculators will actually find that first angle for us. So if you put in your calculator, theta equals the inverse of sine 0.8, you will get that that angle is equal to 53 degrees. And I'm going to identify that as the reference angle, which is the angle that our calculator finds for us. Here, our reference angle is a solution because it's acute, and we have identified by drawing these triangles that we should have an acute answer. So the idea of this reference angle will become more clear as we go further on in the lessons. For now, I'm just introducing the term. So the calculator found this first angle, the acute angle for us, but it's not going to find the obtuse angle for us. It's not able to do that. So we have to calculate that ourselves. So if this first angle is 53 degrees, that means the angle in this right angle triangle is also going to be 53 degrees. So I'm going to label that as 53 degrees. So then to find the obtuse angle, it's 180 degrees because if we're going from the positive x-axis to the negative x-axis, that's a straight line, which is 180 degrees. But we're going to take away the 53 degrees because we didn't quite go far as 180 degrees. So the other angle, so I'm going to say theta 2, and this one should be theta r or theta 1, is 180 degrees minus 53 degrees, and that's 127 degrees. So in the end, you can say your two solutions, 53 degrees and 127 degrees. And then you can check that with your calculator. In your calculator, if you type in sine of 53 degrees, you should get the ratio of 0.8. And if you type in sine of 127 degrees, that's another angle that gives you that same ratio. So this is your first look at looking at two different angles that give you the same ratio. So in our last example, C, it's very much like A, we want cos of an angle that gives us 0.43. So you have to remember that the cos ratio, we're talking about x. So where is 0.3 along the x-axis? So we're going to the positive this time, right? And then you are going to go up to the unit circle, and then that's your right angle triangle. So we know we should have an acute solution. So cos theta of 0.43, use your calculator, and you have 65 degrees. There's only one solution between 0 and 180. That's the only place you can draw that right angle triangle that has this x value of 0.43. So the big takeaways, because these are some new ideas, are that the cos ratio is positive for all acute angles between 0 and 90 degrees. So if you see that the ratio is positive, you know you have an acute angle if it's cos. If the ratio is negative for the cos of an angle, you know that you're talking about an obtuse angle. The angle is between 90 and 180 degrees. And finally, the sine ratio is positive for all angles between 0 and 180 degrees. And that means that you have two solutions. One is acute and one is obtuse. So you find your first one, the acute one first, we call that the reference angle. And then to find that obtuse angle, the second solution in quadrant 2, you take the first angle and you take that away from 180 degrees.